This is lesson 25, a continuation from yesterday's lesson. With a partner, graph and label each using the slope y-intercept method on the same set of axes. So here, y equals x minus 1, our slope equals 1 over 1, or 1. Our y-intercept is negative 1, or 0, comma, negative 1. Our equation for number 2 is our slope is 2 over 1. Our y-intercept is negative 2, and 0, comma, negative 2. So now that we want to graph these, okay, we are going to graph these, we have 0 and negative 1 right here. And we have 1, up 1 and over 1, up 1 and over 1. I'm going to go down 1 and over 1 here so I can graph that. So I am going to draw my line. And again, remember to go through the entire graph there. Label your line. We have y equals x minus 1. My second line we have, I'm going to move this up just a little bit so we can all see. Trying to get it away from that glare. I don't know why that glare just keeps staying there. But now to graph that second line, we start at 0 and negative 2, which is here. And our slope is 2, so we're going to go up 2 and over 1, up 2 and over 1. And we are also going to go down 2 and over 1. So here are our points for that one. So I'm going to draw that. And again, through the entire graph. And our graph is y equals 2x minus 2. So it says name the ordered pair where the graphs of the two line equations intersect, and that is right here at 1, 0. Verify that the ordered pair name in question 1 is a solution to y equals x minus 1. So we have y equals x minus 1. Substituting that in, we have 0 equals 1 minus 1. So 0 equals 0, and that checks. To verify it with our second equation, we have y equals 2x minus 2. So to substitute it in, 0 equals 2 times 1 minus 2. So 0 equals 2 minus 2, or 0 equals 0, and that checks. And for the last part, it says, could the point 3, 4 be a solution to the system of linear equations? That is, would 3, 4 make both equations true? Why or why not? No, because it has to be a solution for both. So if I substitute it in to both of these equations, so we have y equals x minus 1, substituting it in here, we've got 3 minus 1 equals 4. 4 does not equal 2. In our other equation, though, we have y equals 2x minus 2. We have 4 equals 2 times 3 minus 2. We have 4 equals 6 minus 2. 4 equals 4. So though it does work in this solution, it does not work in this one. Okay? All right. Next. From the previous lesson, this should be a y, first of all. Okay. This is called a system of equations. So we're going to try another one. So first, let's do the work. Let me move this up just a little bit. Here, we don't have this in slope-intercept form. So the first thing that we are going to do is put that in slope-intercept form. So we have x plus y equals 2. I'm going to subtract x from both sides. So now I have y equals negative x. Sorry, that's a minus negative 2. Sorry, fix that. So that should be y equals negative x minus 2. So our slope is negative 1 over 1. Our b, or y-intercept, is negative 2. And at 0, comma, negative 2. Our other one, we have y equals 4x plus 3. So our slope is 4 over 1. Our b is 3, or 0, comma, 3. So now we are going to graph these. I'm going to graph this one first. So we have 0 and negative 2. But notice our graph goes by 2's. So we're going to go up 1 and over 1, which will be right in the middle here. And, sorry, it's negative, so it goes down. So down 1 and over 1. Down 1 and over 1. I'm going to go up 1 and over 1. So we have our 4 points. I'm going to draw my line. And again, go through the graph. Label your graph with the original equation. Now I'm going to graph the other equation here. So we have 0 and 3, which is right here. And we can go up 4, 1, 2, 3, 4, over 1. And I'm also going to go down 1, 2, 3, 4, and over 1. And I have our 3 points. Actually, I'm going to make one more point. 1, 2, 3, 4, and over 1. I have 4 points. I normally like 4 points, as I said before. So we are going to graph this line as well. And we have y equals 4x plus 3. It says, what is the solution? So I'm going to move this up. What is the solution to the system of equations? And here we have negative 1, comma, negative 1. It says verify your results. So let's put them into both of these equations. So we have x plus y equals negative 2. So I have negative 1 plus negative 1 equals negative 2. Negative 2 equals negative 2. My second equation, we have y equals 4x plus 3. So negative 1 equals 4 times negative 1 plus 3. Negative 1 equals negative 4 plus 3. Negative 1 equals negative 1. And they both check. Now, our last problem says write a system of equations with 1 comma negative 2 as the solution. Now, a little hint here is to plot a point. Plot the point before you create your lines. And that ends our lesson.